we will switch to 2.2, which uses this data that we just downloaded to run the composite. So what you need to do, because here we tell you where the data is saved, you need to copy this path. Just copy this path, and you will need this path to inform this new exercise where to read the data. So again, here we are importing, because we will be reading netcdf files. Again, we need the netcdf4. We also import NumPy, and we will also be importing matplotlib. So this notebook you open from the same location, time series analysis, 2.2, monthly composite from daily images. And we import, we do the import for first and do the import for the second. And here, of course, because this one, you can either, for input dir, you can either just simply indicate the full path, which is this one here. You can indicate it like this, or because we are inside this time series folder, we can simply copy the later part, which is this one. And then put here. So when we copy and put here, meaning that dot means current directory. Current directory is all until here. So then we don't need to write all this long string. We can limit current directory, absolute is the long string, and then we join with the later part, which is this one. And then we will output to this file. We call it month. So here we will generate a month composite. So our variable inside the file, we have this chlorophyll A. If you have a software to open it and see it, yeah, you can see the variables. But I will also demonstrate how you can see what kind of variables are inside the netcdf using this netcdf4 package. So here we define the variable, and the composite is month. And then this one, if it doesn't exist, we'll create it. And then inside this input file, we use the glob function. The glob will try to find all files inside our directory matching this pattern. So if I do glob, then I see a list of all files here shown here. So we run this one, and then this is just for efficient memory use. We pre-allocate the images. So we know the number of images here. We can count from the input list. And because all these images have the same size, we can create empty array that will store all the data with fixed size. So this is very, it's a good way to work with a large array to avoid memory issues. So this function is simply to pre-allocate, create empty array that we will be using to input the data. And then here, we will get, this is the file, just one file where we want to read the information of the size, X and Y size. The T, which is time, we can know it from the length of input. So here we have the file and the T and the variable name. Of course, I say that I can demonstrate how we can see what kind of variables are inside. If you use dataset, we can call it NC equal dataset and then we read this file here. This flag says read, and then we can say NC variables. So this NC is alias for this opened netcdf file. And then here we call variables, and then we say keys. So this one will tell you all the keys. Oh, okay. The function we call is this one. So this one will tell you all the keys. Here inside this file, we have time, we have CRS, we have lat, we have long, and we have chlorophyll. So in this case, we're interested in the chlorophyll. So this is the variable we defined here. And we will be using this one. So we pre-allocate here, data will have a shape that will be the X and Y and Z and T size. And here we'll loop through the files. Here I just create a simple line to display you the progress bar, and then I will be reading each file. So here I'm putting, for each file I read, I put here inside this pre-allocated data here. And then once this reading ends, we will count the number of pixels in each point, how many valid data existed in each pixel location for our composite. And we will also generate the mean for our composite. So once this whole thing is done, we get composite done, and then we'll move on to the next thing. So this is, because the images are very small, this is very fast. So it finished in less than 3 seconds. And then now we have the count image, which is a number of valid pixels for each point in the map, and the composite, which is the mean. So we can try to show or display using matplotlib. Matplotlib will help us display the results. So we'll read the long in lat, which is the geolocation. And yeah, here we, for the chlorophyll, we can use we use this log norm because the chlorophyll has log norm distribution. And for the first part is for the chlorophyll, and the next part is for the count. And if you run this, you will have these two images showing. On the left, this is the chlorophyll, and this is the color bar for the chlorophyll. Here is 0.01, and here is 10 milligram per meter cubic. And here is the count, so you can see where you have within a month where you had more pixels and where you had less pixels. We see less pixels inside Triangle Bay. This area suffers a lot from clouds, so there is a lot of missing data within a month. And here we see more pixels. So here we can do other things that, for example, you can be interested in adding, for example, the name for each figure or the color bar. One thing you can do is to say PLT title, and then you can say the title of your, for this one, we can say chlorophyll A, and then I think we need to indicate the axis, just like we did here, indicate that we are adding this one to this. Okay. In this case, looks like we cannot specify. So we can use the axis itself, axis 0. And then now we say set, instead of title, we say set title. And then we say chlorophyll A. then we have the chlorophyll title here. We can do the same for the count image, so we know what kind of data is this we are dealing with. Okay. And we can output this image into a netcdf file. So after we have the data processed, we might be interested in saving the data. So we have our output directory. We can join to this output directory the file name. In this case, I'm saying this is April composite, monthly composite. So I indicate here inside our modules, we have a function that help us save with the name NC-write. So this accepts the file name, the data, the variable name, long lat, and the count. So valid pixel count. So if I run this, it will save our netcdf, and it will tell us that it only took 200 milliseconds to save the file. So we can check here, SGLI, now we have month. We can confirm that the file exists there. So it was able to save this file. Yeah, that's all for this exercise. Please try it, and if you have any issue, let me know. You can also experiment with different, you can experiment by downloading different data from different sensor or different subregion and do the composite. But it's nice if you could confirm first that all these things, all this exercise as it is, you can run it successfully. So please try it for about 5 minutes, and then we can have 5 minutes break. So first we download using the time series download notebook, and then after that we use the time series composite notebook to generate our composite. Okay, someone got error, index error. Can you make the screenshot of the error? This error probably is about the size of the data. Something has to do with And if you can get the files, you can read the files. You have all the list of files. You should be able to run. Just make the screenshot and share so we can know exactly what kind of error it is. Yes. Thank you. So do you have any, below this index error, do you see other information below this? Okay. Yeah, so yeah, we can try to solve it during the break. So I believe everyone is running it without any issue, except the issue we received here. So if no one has problem, let's take 5 minutes break and resume 5 p.m. Japan Standard Time.